Hello, in this video I want to talk you through the research methods topic, and this is useful for both paper 1 and paper 2. I'll put it on full screen actually. So for paper 1, this is where you have to design your own piece of research, and you obviously need to know all of research methods knowledge to be able to design your own piece of research. So once I've gone through this PowerPoint, which basically discusses all of the research methods topics, I will do one of the sections in full for you on a video. So in the past, so these are all the different past paper question years that have been on, and we've got the different research methods that they've asked about. So they've asked about a questionnaire twice, we've got a correlation twice, and we've got an experiment 3 times. What's really interesting about this is that they've never asked about an observation, which is the other main research method. So whether that means that the one that's coming up this year is an observation or not, who knows? They might go for another questionnaire or correlation because that's not been up as much, but they do quite like asking about experiments. So it's not really predictable, but it's interesting that observation's not been up before. Now, for every single research method question on both paper 1 and paper 2, you need to make sure that you put every single answer in context. And what that means is that if you have a piece of research, the scenario that comes either on paper 1 or paper 2, and it says something like you've got to do a study on chewing gum and concentration, or another study on music lyrics and concentration, or exercise and happiness, or stress, or bullying, what that means is that every single answer that you write needs to be in reference to that. So you need to put that in your answer, put the word bully in your answer, put the word happiness in your answer. There was one about watching a film, put the film in your answer. So any kind of reference, what it's about, snacks, whatever it was, that needs to be in every single answer. And if it's like a 4 mark, then you need to do it for each 2 mark point. So every point that you make needs to be in context. So even if it feels like you're repeating yourself, you need to do that. Now, context is not rewriting what the study is about at the beginning of your sentence. It's always kind of like at the end of your sentence or in the middle of your sentence as you're giving examples. So giving examples is a good way of getting that context. So it's not simply rewriting what the study's about. So some people get confused and think they've done it when they've not. So that's something to kind of bear in mind. One of the topics on research methods is aims and variables, how to define them. And sometimes we use the word operationalise for that. Now, the aim of a piece of research, and so you could get asked this on either paper 1 or paper 2, is the purpose of the investigation. So you might be asked to define what one is, and you might also be asked to write an example of one. So, for example, to investigate whether learning is affected by time of day. It always starts off with to investigate. You could put to find out, but it's not very kind of academic to write like that. So to investigate is better. And then again, this one is a clearly an experiment because we're seeing whether it's affected. If it was for a correlation, it would be to investigate whether there's a relationship between the 2 variables. You mentioned what those 2 variables are. For a correlation, the variables that are in a correlation are called covariables. And these are just basically 2 variables that are being measured. So we don't have like IVs, DVs, EVs in a correlation. They don't use those kind of terms. And the kind of what we'd class as an extraneous variable is actually called a third variable in correlations. Same kind of psychological concept, the same thing, but they just have different terminology and the different research methods. So for example, in this one, might be asking to do a correlation between how much exercise people do and how happy they are. The theory is saying that the more exercise they do, the happier they are. So they're actually saying that the theory is that there's going to be a positive correlation. So it might ask you to write a directional hypothesis, and then you could put there will be a significant positive correlation between these 2 variables, or use the word relationship rather than correlation. And then for an experiment, we've got IVs and DVs. So IV being the one that you are changing, the one that you are manipulating, the one where you've got 2 conditions. Usually, obviously, you can have studies where you've got more than 2 conditions, but of all the ones on the GCSE course, it's usually 2 conditions. So we've got, for example, music is the actual IV, the thing that's been manipulated, and then we've got the 2 groups. We've got with lyrics, without lyrics for this particular scenario here. And then the DV, the thing that's being measured. So we've got concentration is being measured here, but the way that they're measuring it, So the operationalised part of it, the way you define it, is that they're using a written task here, whereas you could have used any other task. So you kind of just need to make reference to how are the variables actually being measured. Obviously, on this one, they weren't operationalized. So sometimes if you look in the scenario, it might say like they've got a rating scale or whatever. You just need to put that in brackets after it to fully like operationalize it. On some kind of questions, they're okay with you not operationalizing it because it's not in the scenario. But if it is in the scenario, it's better to put it on. And it's always good practice as well, because if you plan on doing A level, then you've got to do it all the time there anyway. I feel like I was going to say something else, but it's gone out of my mind. Yeah, usually they ask you to either say what the IV and DV is, say what the core variable is, or say how you'd like make it measurable. Sometimes if it's saying say the IV, I'd operationalize it anyway, just to kind of make sure you don't drop any marks. We've also got extraneous variables in experiments or third variables in correlations. You can't really control for a third variable in a correlation, but for an extraneous variable, you could control for it. And you could do things like standardizing the procedure, making sure everything is the same. I've got an example here about from this scenario about how you're listening to lyrics or not listening to lyrics might have an impact on your concentration on a written task. And EV could be the type of music. So you might prefer rock music or punk music or whatever it is, that might have an impact. It might be nothing to do with the lyrics. It might be quite difficult to concentrate. For some people listening to rock music, but for other people, they like it. So, you might get differences because of that. So in the exam, you could be asked for what is an extraneous variable, but you could also be asked, how do we control for that? How do we make sure that that doesn't have an impact on our DV that's being measured? So for example, on this one, we might, in fact, does it say? It doesn't say on here how we control. Oh, there we go. We could control this by making sure participants are played the same music, and the only thing that's changing is the lyrics. So that is a control, but then it doesn't really get around the problem of them preferring certain types of music. Um, I'm trying to think of something else that you could say. You might say something like the volume of music. That's probably a better one to use as an extraneous variable, because then you can say I'd keep it the same volume for everybody. Whereas if you do type of music, that controller doesn't really control that, so it makes it a little bit odd. So yeah, it probably would be better to say like the volume of music, or anything that might have been like slightly different between participants, or the fact that they wear headphones or something like that. No, they are probably going to ask you to write a hypothesis, because it comes up quite frequently. If it's not on paper one, it's probably going to be on paper two. And this is a prediction of what you're going to find. The reason why they ask this a lot is because people drop a lot of marks on it. So we'll use the same scenario as before. Now, for an experiment, I was going to check actually on the spec if you needed one tail or two tailed. I don't. It's a A-level thing where you need one tailed and two tailed and things like that. Maybe it's just I might just have a little quick look. Let's see, GCSE spec. Let's see what it says about hypotheses. So obviously this is the spec of things that you need to know. So it only says about null and alternate. Yeah, so it doesn't say anything about one tailed and two tailed, so you don't need to worry about that actually. So let's see. So all you need to know is the difference between an experimental and a null hypothesis. So an experimental is where you're saying that there's going to be, and this is for experiments, that there's going to be a significant difference between the conditions and how it affects the DV. So in this one, we've got concentration on a written task, our DV, so we've got to fully operationalise it, say how it's being measured in the hypothesis, as you would do when you do the variables as well. So we've got there'll be a significant difference in the DV between whether, so it's just the way it's worded. So you always say there'll be a significant difference in the DV between whether and then you've got the two different conditions. So here we've got participants listening to music with lyrics and music without. So what that means is there is going to be a difference. Maybe the ones with lyrics are going to be more distracted because they're kind of singing along or something like that, or people listening kind of and then not concentrating on the written task. Whereas the only difference between this one and a null one is there will be no significant difference in concentration on a written task between whether, and then we've got the two conditions. So nice and easy. We just need to make sure that we've got a difference. And we've also mentioned the DV fully operationalised and the IV fully operationalised. It's a bit easier to remember to the IV because you're putting on, well, that's my Debenhams parcel, you're putting on the two conditions. Now, for a correlation, it's slightly different. We can't use the word difference because we're not looking for a difference on a correlation, we're looking for a relationship. So we change the word to a significant relationship. So we've got between how much exercise people do and how happy they are. Now notice this one's not been operationalised because on this one here, it wasn't operationalised. If you're on paper one and it's asked you to define the variables, then you want to make sure you define them in your hypothesis. Personally, I would just put something on anyway, but on some mark schemes, it doesn't say you have to do it. So sometimes it just lets you get away with doing it like this. If it was a directional one, then the only difference is you put the word positive or negative because there's the two types of correlations that you can predict. I feel like there was a question about that on a past paper, but it's not on the spec, which is quite confusing. Or maybe that was on an A-level paper, I'm getting confused. But in case that happens, you know the difference now. And then obviously for a null hypothesis, it's there'll be no significant relationship. And then again, we've got the two variables. So nice and easy once you know how to do it. And they're probably going to ask you a hypothesis question, either on experiments or correlations. You might be wondering, like, how do I know which one to do? In the actual scenario of the paper, it's in bold what research method it is on paper one. And on paper two, it'll be clear because if you read it, it'll say an experiment has been conducted, or they're looking for a difference, or they're looking for a relationship. It will be really clear what it is, but you just got to read it in the scenario. And then sampling methods, techniques. We've got three types that you need to know. The volunteer one is sometimes called a self-selected, so you need to remember that that is also a volunteer sample. So you could be asked to say how you would do one, which is usually quite often in the paper one, and then also what the strengths and weaknesses of them are. So for a volunteer, you need to say you're going to put a poster up, and it could be a flyer as well. It could be, you know, anything like that, newspaper, advertisement, whatever. But the poster is just easier to do. You've got to say where you're going to put it. So where you're going to actually put that poster, because we need enough details really. And then we've got to say what is going to be on the poster. So things like the actual aim of the study. Don't worry too much about, you know, then there'll be demand characteristics. It doesn't matter. Like you're going to get marks for saying what's on the poster. And then it's like, don't overthink it, is what I'm trying to say. And then you need contact details on there. And you need to specify that that means that the participants will be able to get in touch with you to take part in a study on. And then you put your context in. So your context needs to be in there. It's quite difficult to put context into a sampling question. So you've got to like say, I'll contact the participants and ask them if they want to take part in the study on how much people exercise, how happy they are, for example. Now, for an opportunity sample, we've got people, this is the key phrase that you need, people that are available at the time. So you just go up to people and say, do you want to take part in the study? So they're usually like on a street. So again, for this one, you've got to state the location of where you would go to pick those participants. You also have to ask them, do you want to take part in a study on? And then that's how you get your context. For a random sampling, a bit more tricky, we've got to have a list of participant names. So you need to say, where are you getting this list from? So it can be the electoral roll, but obviously if you're below 16, you're not going to be on the electoral roll, so you've got to be careful. School registers, hospital records. Obviously, in reality, you're not going to get access to those, but for the purpose of the exam, you can still put them, it's fine. You also then need to say you're going to put the names in a hat. Don't say you're putting the people in the hat because the hat's not going to be big enough. And then you need to pick out the number of participants. You need to state how many participants you would pick. And then you've got to ask them if they want to take part on the study about, state what it is, you get context. Now, some strengths and weaknesses of these are, for a volunteer one, very quick and convenient. And the reason for that is because the participants come to the researcher, so they just have to put a poster up and wait for them to get to you. And also, because you've got what the study's about on your poster, you're not going to have any issues with ethics because they've given informed consent, and you're not going to have any issues with like them dropping out, which is called attrition. So your sample will be still representative, although The disadvantage of a self-selected sample is that it's not representative because you've only got a certain type of person, someone who's really confident and outgoing, that's going to put themselves forward. So it's not going to represent everybody, particularly if what you're investigating is quite, you need people who are of a range of different confidence levels. Like, for example, if it was on bullying and you got all the confident people, they might not have been bullied, because it's usually people that are less confident that get bullied. So that would be a massive issue in that kind of study. Strengths of an opportunity sample, again, it's quick and convenient, but this time it's for a different reason. It's quick and convenient because they're available at the time, they're already there. And again, you use the definitions in your strengths and weaknesses to get a better answer. So you need to know those definitions really. But the issue is this one's going to be biased. You're going to have a lot of researcher bias because the researcher who's going up to the participants to pick them, they might pick people who are quite friendly looking or kind of like maybe fit the aims of their research. And then again, it won't be representative of everyone. You can make points about how you've only been at one place in time. So there is kind of like cultural bias and things like that, but you're veering away from what the actual sampling technique is about. So this one's a little bit more direct. The other one, you're risking losing some marks because it's not as specific. And then for a random sample, most representative sample, because everyone's got an equal chance of being selected, and that's the definition of random, which is why you need it. Again, you might just be asked for the definitions of these as well. And then we've got issues. So it's difficult to gain access to everyone's names because who can get access to hospital records or a school register? They're private, aren't they? And then if anyone doesn't want to take part in the study, you've got to rerun it again because those people that don't want to take part, that means your sample becomes unrepresentative. So you've got to run it again to maintain that representativeness. And it's very time consuming because of this. So you can put time consuming as negative as well. So you've got to say why I mentioned that. And then we've got ethics. So you need to know that the ethical guidelines come from the British Psychological Society. I think there's been a multiple choice question on that before, but again, I might be getting confused with A level. But it is on the spec because I just looked at it before. And then on the spec, it says that the ethical issues are informed consent, so have people knowing the aim agreed to take part, protection from harm, have you protected them from psychological and physical harm, so they can't experience anything more than what they would ordinarily in their everyday life. And then on the spec, it says ways of dealing with them are the following. Oh, I've just realised I've made a mistake. Let's just get rid of this and I'll edit it now if I can. Yes, let's see. So for ethics, deception is actually an ethical issue. Another way of dealing with it is confidentiality. The reason why I've not put confidentiality on is because if I was you, I would avoid suggesting confidentiality because it's a bit more difficult to explain. And a lot of people put it and then they don't really get the marks for it. Again, deception's one that people lose marks on. So if I was you, I'd try and do informed consent protection from harm or right to withdraw. They're the easiest ones to do, but let me talk through them. So deception is when you lie to somebody about either the aim of the study or your role in that study. So say, for example, if it's a participant observation and you've become part of the group and you're like, I don't know, at a football match and you dress up as a football fan, you're lying about your identity because your real identity is a researcher. So you've got to kind of be really specific on that one. Whereas the other ones you can get away with not saying very much. And then ways of dealing with it. So we can debrief them at the end, which means that we can remove the harm because we can signpost them for psychological services like counselling. We can give them the right to withdraw their data. And we can also remove the deception by telling them about the true aims. Or you can give them a right to withdraw. So this can be like at the beginning, you can say, oh, you can leave anytime you want. Or you can remove the data in a debrief afterwards. And then obviously confidentiality means that everything's anonymous. You can say to them, like, we're not going to publish your name and stuff like that. So again, that comes under ways of dealing with them. But yeah, if I was you, I'd do protection from harm, right to withdraw, informed consent. They're the easiest ones. So you might get questions that say, how would you ensure that there is ethical issues in paper one? Or in paper two, you might be asked to like define an ethical issue or spot it in a scenario or something like that. Experimental methods. So people get these confused with experimental designs. So a method is a research method, type of research method. So a research method is an experiment with three types: so laboratory, field, and quasi. So laboratory experiment, manipulate an IV in a controlled setting. Field experiment, manipulate an IV in a natural setting. Quasi experiment, you've got a naturally occurring IV. IV is what you're changing, that's the groups of your conditions. So, for example, in a lab experiment, if I was interested in litter being affected by the presence of a bin, then I might bring them to my lab. I'll have a bin while they're eating something, and I'll see whether or not they put it in the bin. And I'll have two conditions. I'll have one where the bin's close to them and one where the bin's far away. If I did that as a field experiment, I'd still manipulate the same IV and have a bin close, bin far away. But this time I'd do it in like the restaurant at school, and then that would be their natural environment. If I was doing a quasi experiment, I wouldn't be able to do that study as a quasi because the IV of the bin being close or far away, or in actual fact, it could be a quasi because that could be naturally occurring. I might do it in two different environments where the bin is close to them just naturally, or the bin is far away naturally. Like, for example, I might look at students who drop litter and do the ones that are further away from the bin, drop it compared to the ones that are close to the bin. I could do it as a quasi, it's a bit harder. But yeah, an naturally occurring IV is something that you can't change as a research. So it's usually something like a participant variable, like their age, their gender, whether they've got a disorder of some kind. Um, and so the strengths and weaknesses of these, the lab and field are the opposite of each other. So we've got laboratory experiment lacking ecological validity. The way people behave in a lab is probably not like how they would in their everyday life. So because it's artificial, we've not got real, um, accurate findings about what people would do. Demand characteristics are more likely. People are more likely to twig that what the aim is and please or displease the researcher. Don't write twig in your exam. So like catch on to what the experiment's about. Whereas in a field experiment, really ecologically valid, like that is their real world behaviour because they're in a natural setting, they're more likely to be comfortable, they're less likely to show demand characteristics. Not impossible to show demand characteristics, but it's less likely. And then the positive of laboratory experiments, high control, means everything's standardised. You can establish causality between the IV and the DV. It's easy to replicate, which makes it reliable. Um, Whereas for a field experiment, there could be loads of extraneous variables that you can't control for, which means you can't establish causality, which is validity, and also you can't replicate it again, which means that it's unreliable, inconsistent results likely. Whereas with a quasi, it's again ecologically valid because the IV is naturally occurring, it is their natural behaviour. If you think about like Piaget with the different age children, well, it is their natural ability to conserve. Like you can't do anything about that. So that it's accurate about how they would behave. So it's valid. But difficult to infer cause and effect because you don't know like what other EVs there are. You don't know, say for example, it's on autism or depression. You don't know the extent to which some people have it or not if there's a spectrum. So it's difficult to make comparisons between participants. You usually have a small sample because there's not many people with autism and depression. They're a bit more difficult to question. Or experiment on. And then also it's impossible to replicate because the next time you do it, you're going to get different people with different levels of that thing that you've got. So like autism and depression, even something like gender, like, how masculine or how feminine you are or whatever will be different. And then designs, this is the one that people get mixed up. And for this question, people always put lab field quasi, which is obviously an experimental method. So for a design, you just have two options, independent measures, repeated measures. For repeated measures, participants do all the conditions. So for example, with the one that we did a while ago, lyrics, no lyrics, they do both of them. And then they get compared against themselves. So they score on both of those to see if there's been any change. For independent measures design, you do one condition of the IV and you compare against somebody completely different. Now that's a bit of an issue because you're going to get individual differences, so participant variables. Somebody's memory might be completely different to somebody else's, somebody's concentration might be different to somebody else's. There could be different things about those two people that you're making the comparison against that mean that we've not got a valid comparison. It might be other things that are the reason for the differences in the DV instead of the IV. So we'd have that as a kind of extraneous variable. Whereas for a repeated measure, we don't have any issues with participant variables because it's the same person doing both of the conditions, so there's no issues with that. They're the same person. And then for the positive of independent measures, you don't have demand characteristics because you've only been exposed to one condition of the IV. Notice how my explanation there was the definition of what the design is. So you need that when you're evaluating, same with the sampling techniques from before. Also, you've not got any order effects because an order effects are like practice, fatigue, and boredom. So practice, you get better, fatigue and boredom, you get worse. You're not going to have any issues with those because again, you're only doing one condition. Whereas in the repeated measure design, by that second condition, you're either going to guess what it's about and show demand characteristics or less valid because you're going to please or displease that researcher, or you're going to get tired or fatigue effect or bored likely. So then you're going to get worse on that second condition. and then you might also get practice effect to get better. Now you can control this. So another example of a control is to use counterbalancing, which is where you split your participants in half. Half of them do condition A, then condition B, and the other half do condition B, then condition A. So the second condition is different for half of them, which means that they balance out any of these order or demand characteristics or effects or demand characteristics. So you can control for them, but obviously you can still put them as a disadvantage for repeated measures. The only issue is if the scenario is said, or you've said in paper one you're going to use counterbalancing, then you can't use that as a negative for repeated measures. Don't make sense. So you've got to kind of be careful. Like, I mean, it won't matter on paper one because I don't think you'll ever say anything about counterbalancing. But for paper two, if in the scenario it says it's use counterbalancing, you can't like use that as a disadvantage really because it isn't a disadvantage anymore. Questionnaires is another type of research method, so a self-report. And this is where participants report on their own behaviour, either on paper or online. Usually closed questions are used, and these have got the like preset selection of answers, so they've always got an option underneath them. So if you are suggesting a question, like a closed question in the exam, because they might ask you for one, you need to put the options underneath. So say, for example, it was a rating scale. You'd say like, how happy are you this week? And on a scale of 1 to 10, 1 being very sad, 10 being very happy, you've got to define what these are. Then underneath you'd have to put 1, 2, 3, 4, 5, 10, whatever. If it was a yes no question, you've got to put the options yes no. So the options need to be on there because you need to show the examiner that you know that there's preset options on there. Otherwise it looks like an open question, because an open question might be, how happy are you? And then it's just open for them to kind of say whatever they feel. You got to be careful though that the question that you're saying on the open one isn't like a yes no response. Like, did you brush your teeth today? Well, it's either going to be a yes or no, isn't it? So that's not really an open question. An open question is where you get to expand, and you can put like why on the end if you're struggling, but it's better to put like one that is like a really open one, like, I don't know, tell me about a time that you were bullied at work, for example. So it's a little bit more kind of it's a lot more open. And then we've got a Likert scale. This is where you've got strongly agree, neutral, disagree, strongly disagree. There are different versions of this Likert scale. So like some of it might not be these, but so for example on the Braun study you've got like I think it says a 6-point Likert scale. It means that theirs is slightly different. So some Likert scales might be. I mean it's a bit odd because really Likert is this one, but other people have kind of taken that in their research and just tweaked it a bit. So you might have like very good, very, very good, sorry, very, very good, very good, good. So that's 3. Then you've got neutral, and then you've got bad, and then you've got very bad. So you can do a 6-point, but anyway, normally it's 5, which is what the standard one is. That's the one that you need to know for research methods. Obviously for Braun, you need to know the 6-point one. So these are 2 examples of closed questions, and obviously you've got the fixed choice yes no options as well. And a positive of using questionnaires is that they're standardised. You've got the same questions, easy to replicate, means it's more likely to be reliable. It also gets quantitative data from the closed question, which are easily to analyse and compare because they're objective. Now, the issue when you are evaluating questionnaires on paper 1 and paper 2 is you've got to be careful that you don't just use quantitative data. You've got to really specify that those are from the closed questions that might be on the questionnaires. Otherwise, you're evaluating the type of question, not the use of a questionnaire. So you've got to be careful. Also, you could say as a positive, which is a bit more specific for questionnaires, is that they're the only research method that allow you to investigate what someone's actually thinking and feeling. So you get their actual thoughts. So if it's something like depression, that's really useful, isn't it? Because you can't observe that or experiment on that. But a disadvantage massively is that you've got social desirability bias. People lie to look better, so to look good. They don't want to admit when they've done something that's not very nice. So I don't know, say it was on parents and smacking their children, they would lie and say that they don't do it because why would you admit that? And therefore results are less likely to be valid. Also on this one, you might have like ambiguous questions that people don't understand what they mean. So I hope you can't see that email coming up. So that they misinterpret the question, therefore they'll give an invalid response. Or it could also be that if you've got a rating scale, they don't understand what the numbers mean. Obviously, you can't use that if it's a Likert because you've got descriptors, but on a rating scale 1 to 10, what's the difference between 7 and 6? It's quite, or 6, 7, it's quite similar, isn't it? And so therefore, that might create kind of either invalid, which means it's not their real response, or unreliable. So say they did it again, they'd do something completely different because they can't remember what it was the first time. Or unreliable between participants as well, because you might get inconsistency between how participants have interpreted it. The other self-report is interviews. So on this one, you need to know structured or unstructured. So obviously, if it's on an interview, then, and notice as well, actually, when we had a look at the designing your own research, they've never asked one on interviews either. So maybe it could be on interviews this year. So a structured is you've got a clearly defined topic, and the key thing that's on a lot of mark schemes is there's preset questions in a predetermined order. So it's a little bit like a face-to-face questionnaire, if you will. Now, this means that it's standardized, so it's reliable, which is a strength, because you've got the same questions every time, and therefore you've got consistent results from people. You've also got kind of quantitative data, but I would avoid that because, again, you're talking more about the question type rather than about the interview. So you kind of want mainly the interview. Another actual positive of an interview in general is that you get to build a rapport with the person, which is a little bit like friendliness. So they're more likely to be kind of valid with you, which you can't really do on a structured, but you can do on an unstructured. That's a positive and unstructured. An unstructured is where you've got the topic, but you don't have any questions. So you can just make them up as you go along. So again, when you define it, you want to put there's no preset questions. It's more like a conversation. You just ask a lot of follow-up questions. You're talking freely. So it's less formal. People feel comfortable. They're more likely to give you valid response. However, it's not standardized. It's different questions every time. So it's going to be unreliable and inconsistent. Now, for the structured one, they might feel really uncomfortable and show social desirability bias. So they're going to lie because someone sat in front of them. Like on a questionnaire, oftentimes they're anonymous, so you're probably not going to be bothered, and so you probably won't be affected by social desirability bias. But in an interview, they're sat right in front of you, you're probably going to be a little bit more embarrassed. You're probably more likely to lie. Also, a disadvantage of interviews is, and the reason I'm saying this is because there was a question that said, what's the disadvantage of interviews that's not social desirability bias? So you might also say that there's interviewer effect. So this is where the presence of an interviewer and the way that they kind of like, scrunch their face up or scowl at you or whatever, cross their arms, might make the participant feel uncomfortable. And so they might then change their answers. They might show demand characteristics because they're trying to please or displease the researcher. So that could also be a disadvantage of interviews. And like some other terms, I mentioned ambiguous questions before, and this is the researcher effect that I've just mentioned. And then we've also got a pilot study that they might ask about. It's rare though, I don't think it's actually on the spec. Let me actually just Google and see. So let's see if pilot's on here. No, it's not actually on, so maybe you won't get asked any questions about pilot studies. But anyway, a pilot study is like a really small scale study. So it's like a test run for before you do your main study. So if it's like a questionnaire, you might do a couple of questions, reflect on those, see if anyone misinterpreted them before you actually do the main study. That reminds me actually, a strength of a interview in comparison to a questionnaire, so a disadvantage of a questionnaire, but a positive in an interview, is that because the interviewer is sat right there, if you don't understand a question, you can get clarification on it, whereas you can't do that for a questionnaire. So that's another kind of evaluation point you can also say. And then observations, which has never been up before on paper one, so that could be quite interesting. And we've got lots of different types of this one. So we've got naturalistic and control, which is very similar to kind of like the lab and field versions. Remember, an observation, you're just watching them, so we haven't got any manipulations of variables really. So we can't always establish causality, although some observations do manipulate an IV, but we'll not get into that because that's too complicated. So a naturalistic observation in the person's natural environment, could be at school, at work, etc. Very ecologically valid because that's the way they normally behave, but we have no control over the extraneous variables that might be in the environment. So we can't really replicate it and get the same results, less reliable. We also can't really establish any causality, but I would avoid that one with observations because oftentimes you don't have an IV, so you can't do that anywhere. Then we've got the opposite, which is a controlled. In a controlled setting, you've got people to come to your lab and you've seen what they do. So you're not manipulating anything, you're just seeing what the behaviour is. So for example, you might have some children come into your lab, you've set it up like a nursery, we're having a look at how they play with each other. That would be an observation. Very controlled, we can replicate it really easily, get consistent results, so it's reliable. but not really going to behave how they normally would because it's unfamiliar, it's artificial, may show demand characteristics, please or displease the researcher. Obviously, if you're a child, you can't do that. So be careful on what the study's about, but they don't really talk about children that often, so maybe you could use that one. Oh, I'm talking too much. Then we've got participant and non-participant observation. So a participant observation, the research becomes part of the group they're observing. Notice how that's the definition. We've got to put that in our answers. That's the reason why we've got the strengths and weaknesses. So, for example, if you're observing shopping behaviour, you might pretend you're shopping, you might pretend to be a staff member, whatever. Very ecologically valid because oftentimes, and I suppose really it's ecologically valid because they're in the natural environment, so they're comfortable, they're behaving how they normally would. But oftentimes, with a participant observation, to do it practically, it is where it's covert, where they don't know that you're observing them. So you're going to get real behaviour, really valid. You can actually see what they're doing. It's not like on a questionnaire where they could lie, like you're actually seeing the behaviour. Because oftentimes people don't know how they're going to behave. Like, for example, we learned about social influence, people don't know what they're going to do. So they're not the best judge of what they're actually thinking and feeling, really, in terms of the behaviour. Obviously, they could do their own thoughts and things. And we get lots of kind of qualitative data because with the participant observation, you get really close to the person you're observing, so you can see the context of why they're behaving in that. So that's a little bit more helpful, but quite unethical if you deceive them because you're lying about who you are. You're kind of dressing up as somebody else, for example. And a non-participant is anywhere you're not part of the group, so you're at a distance. It's obvious that you're an observer, although these can be covert though, so you might not be obvious that you're an observer, but you're at a distance, um, and you haven't got that observer effect because people don't know that you're there. So they can't show demand characteristics and whatever. It's also a little bit more objective because you're not, with a participant one, another positive is that you get rapport, so you find out the reasons, but then you lose objectivity, which is a disadvantage because you kind of almost like empathize with them and kind of understand why they're doing what they're doing, which can be a bit problematic if you like investigating gang behavior or whatever. So for a non-participant, um, it's probably going to be more valid because you're more objective. But then, because you're at a distance, you might be obscured, you might be able to see properly. And so it might be a lot more difficult to see what's going on and record that. And also, you don't know the context. So you're requiring a lot of interpretation. So observer bias could be a problem, which is where you write down things that you expect to see. And then we've got covert and overt, which again are the opposite of each other. So covert, you don't know that you're being observed. So think of it like undercover. So cover, don't know you're being observed. This one is more valid because less demand characteristics, you don't know but you're being observed. And then it's unethical because you've not got informed consent that they're being observed. Whereas overt, out in the open, they know they're being observed, very ethical, can give informed consent, can refuse and say, I don't want to actually be observed. But then they might show demand characteristics because they know that you're watching them, which you would do, wouldn't you, if you were like, why are they watching me? You'd be very unnatural in your behaviour, even if you weren't trying to please or displease the researcher. And then we've got correlations, so I was going to say the final research method, but there's also case studies, which are a mini one. But anyway, the final main one, but it could be on in section D, is correlation. So you're looking for a relationship between two variables. As mentioned before, you've got two that have been measured. So for example, how shy you are, how good you are at maths. These are a really good starting point for research because you just measure two variables, plot them on a scatter graph. You can really easily see on a scatter graph if there's a relationship with that line of best fit. Are they close to it? Are they far away? If there is a relationship, then that justifies doing an experiment, and then your experiment can find your causality. Whereas, I was going to say like a disadvantage, but let's do the other strength. So another good thing about correlations is that if it's impractical to do because maybe it's illegal or it's unethical. So say, for example, we wanted to find out about drug use. I can't do that experimentally because I can't get the legal, consent for that. And I also, it's not ethical to like give people class A drugs, for example, just to see what their impact on a certain behaviour would be. So I'd have to just measure that with like some data, there's some secondary data that's already available, perhaps, or conduct my own research like a questionnaire or an observation to kind of then correlate. It's probably more likely that you'd use a questionnaire, I suppose. Now, in your hypothesis, as mentioned before, you want to use the word significant relationship, and we're also using a scatter graph. So if you ask you what type of graph to use, you talk about a scatter graph. That's one where you put the X where the two meet, and then you put a line of best fit on, and it'll tell you whether it's a positive or a negative relationship. And you can also judge like how strong or how weak it is. So a positive is where the variables do the same thing. So as one increases, the other one also increases. As one decreases, the other one also decreases. Got a positive correlation. A negative correlation is downhill. So as one goes up, the other one goes down. And then there are like numbers that tell you about the strength of correlations, but I don't think you need these on GCSE. This is more like an A-level thing. But you might need to know the descriptor. So if the points are really close to the line of best fit, we've got a strong correlation. If they're a bit further away, we've got a moderate. And if they're really disparate, we've got a weak correlation. And obviously, if they're all over the place, we've got no correlation, which is possible. We wouldn't do an experiment afterwards if that was the case. So it's quite, it doesn't cost a lot of money. It's not a lot of time, lots of things like that, that it's positive correlations. And then we've got data types. So types of data that we need to know, quantitative and qualitative. These are probably going to come up because they always ask questions about data. So we've got quantitative is quantity, numerical scores, like on a test. You might need an example, which is why I've put scores on a test. So when you define it, put an example on. Whereas for qualitative, it's descriptive words or pictures, like a diary entry. And then the positive of these, very easy to analyse quantitative data because it's objective. A lot of people miss this word off. Objective means it's no interpretation, it is what it is. So it's easy to make those comparisons. We've not got researcher bias interpreting it. Whereas on qualitative data, because it's subjective, so you interpret it with your own thoughts and feelings, difficult to analyse, difficult to make comparisons, researcher bias way more likely. But disadvantage of quantitative, we don't have any insight into the reasons why they've put those things. They could have just ticked a box, could have been bored or whatever if it's a questionnaire. And then for the qualitative data, we have got those insights and those reasons why. We've got an understanding of what the reasons are for that behaviour. And then we've got primary and secondary. And a lot of the times on the mark schemes, they accept either of these. So you don't need to worry like, oh, it is quantitative, but it's also primary, for example. You can do either. So primary data is when you collect it yourself as a researcher. So that means like all the ones that we've been talking about, if you do an experiment, a correlation, a self-report, interview, questionnaire, all of these case study, experiment, I feel like I've missed some off, observation, whatever, all of those, it's primary data because you are doing it firsthand. So you need that definition firsthand by the researcher, also for the purposes of that study. Whereas secondary data is that we've got some data that's been collected by somebody else for a different purpose that the psychologist comes along afterwards and starts to analyse and maybe put it on a correlation, for example. So secondary data is really quick and convenient because the data is already there. You just got to correlate it or see if there's a cause and effect or whatever. But the data might not actually be valid. When it was collected, it might have been collected wrong. There might be errors in it. It might have been misinterpreted. It might not be valid. You don't know really because you haven't done it yourself. Whereas for the primary data, you can trust that it is right because you've done it. And it hasn't been interpreted by somebody else. However, primary data is far more time consuming and costly because you're the one that has to go and conduct it if you're the researcher. And then we've got case studies. Now, case studies is you only end up getting like the odd question on paper one. I think it's come up once before, and it said like, "Oh, this is like a questionnaire. How would you have done it as a case study?" I think it was about the one about teachers being stressed compared to other professionals. I think it was on that year, and essentially a case study, and you might be asked to define it in paper two or pick it out of a scenario maybe, is an in-depth study of one individual or a small group of people over a long period of time, and usually get lots of qualitative data. So I think of like Clive Waring in the memory topic, that was a case study on one individual. And what you tend to do with a case study is you collect lots of different information. So you might have a questionnaire, you might have an observation, you might have a little experiment that you do with them. You might do lots of different tests, like with Clive Waring, where he's in the MRI scanner and he's got like an IQ test and a verbal fluency test and all those kind of things. So like the Wechsler kind of test he was doing. So a real massive strength of case study is that you've got a lot of qualitative data from all these different ways that you've collected the data, so you can triangulate all those to give loads of insight and reasons why people are behaving that way. You can also, because it's longitudinal, see change in behaviour over time. And it's also possible to study things that might be a little bit unethical, because obviously we couldn't give somebody amnesia like Clive Waring. And also we've put like, there was a girl called Jeannie who was like just trapped in a room while she was younger, strapped to a chair. She wasn't allowed to move. No one talked to her. And you could have a look at the impact on language development because it was very delayed. Couldn't do that as an experiment, so we'd have to use a case study, so something that is naturally occurring in the world. However, the samples are always unrepresentative because they're only like one individual or a small group of people. So it doesn't say that that's how everybody would behave. So we can't generalise fines to everybody. So we lack population validity. Also, there could be some researcher bias because we've got a lot of qualitative data that needs interpretation. So they could be subjective. And also, if you're doing it over a long period of time, people might drop out. So then your sample becomes less representative over time. Probably less likely to put that one. Probably the ones that are a bit more easier to explain. And then we've got internal and external reliability. So there was a question that came up that asked about external reliability, stumped loads of people. People didn't know what it meant. So reliability is basically if you get the same results every time you do something. So in order to get the same results, you can keep everything the same. So if you standardize all your procedures and you can easily replicate it and do it again, then you're more likely to get the same or similar results. And if you're talking about just your study, then that's internal reliability. So what this means is that every participant that you study has the same experience of that study, and therefore they've got consistent responses. Now, external is outside of the study. So that means that you are trying to see the results that you got on your study. If you do it again with a different group of people outside of that original study, will you get the same results? So you kind of need to mention with external reliability that you'll do it on a different group of people to see if they're the same as your original study. On the mark scheme for the one that did come up, it said something like you could test it on one group of people and then test it again on another group of people and compare the results to see if they change. Or in fact, it might have said they test the same group of people twice. I don't really know why they needed to do it twice, but it is external liability because you see inconsistencies. But if you're doing it twice, you're going to be doing internal reliability because you've done it on the same group of people. If it's on a different group of people, it becomes external reliability. So I don't know if that might have been a mistake on the mark scheme. The other type of reliability that you need to know for observations is inter-rater reliability, sometimes called inter-observer reliability. And what this is when you've got two or more observers that after they've observed, they compare their ratings to see if they agree. And the more they agree, the more inter-rater reliability there is. Whereas if they don't agree, then clearly the interreliability is low. We haven't got it. We haven't got interreliability. You could argue. So you don't need to put high or low. You can if you want. But then that means that there's observer bias. So that means that some of them are, or both of them, are observing subjectively because if they got a high interracial reliability, it would mean that they were being objective about what they were observing. So it's an important measure in observations to take. So things that reduce reliability are asking different questions. So like a questionnaire is more reliable than an interview but then a structured is less reliable than an unstructured. So the most unreliable, I don't know if I said that the right way around then, the most unreliable of those is an unstructured interview, whereas a structured interview, more reliable but less so than an actual questionnaire. Because there could also be the researcher behaving differently. You don't have that problem in questionnaires, but you do have that problem in interviews, you have that problem in observations, you have that problem in experiments. So the way that they behave might have an impact. Like you could have the researcher scowling at one person, but not at the other, for example, being friendlier to one than the other. Ambiguous questions affect reliability because they might interpret it one way at one time point, but a different one at a different time point. EVs would affect reliability because you can't replicate it and get it the same way. Similarly, if your observers are not trained, although it's more of a validity on that because if they're not trained, they're going to be consistently not trained. And then things that increase it, obviously the opposite of that, ask the same questions, behave the same way. So a way to make sure that things are reliable is to standardise everything, keep everything the same. Then for validity, the way that this one's different is validity is about accuracy. Have you actually found correct information? So if we can control for extraneous variables, we can establish causality, which means that we've got internal validity in our study. And internal validity is an umbrella term for lots of different types of validity. And the one that you need to know is construct validity. They're the same thing. What they both mean is, have I measured what I'm claiming to measure? If my study is about stress, am I actually measuring stress? If my study is about happiness, am I actually measuring happiness? And then we've got external validity. So these are outside the study. These are, do my findings represent outside? So ecological validity, do I actually have results that tell me about real world behaviour, how people behave in the real world? Population validity, does my sample represent everybody else in the world? Can I say that the way my sample behaves is the way that other people like in the world behave? Things that reduce it. If you ask a leading question, well, they're not going to give you a real response because they've been led to it. If it's ambiguous, they can also be invalid because you might give a wrong response to it. A closed question, your option might not be there. You might have just ticked some at random, so that'd be invalid. Social desirability bias is a lie, so it's not accurate, it's not valid. Demand characteristics, you're lying to please or displease the researcher, not valid. Order effects, you're bored, fatigue, or practice. Maybe not I don't know actually. Yeah, because it's not valid because it's not the impact of the IV. Any EVs make it not valid because obviously that you can't establish causality. Observer bias or any other researcher bias, also researcher effects. So the difference between these two, and they ask the question about this as well. But researcher bias is when the researcher either subjectively interprets the data to fit their aims or picks specific participants like an opportunity sampling or behaves differently to different. No, actually, that's not that one. I'm trying to think if there was another one. Probably just those two. And then researcher effect is the way that they behave, which is why I stopped myself just before. So are they kind of crossing their arms and they make them uncomfortable, things like that, which then means that they won't give a true response because they'll lie, they'll be more likely to show social desirability bias or demand characteristics, for example. And obviously things that improve it, really clear questions, open questions, if you deceive them, counterbalancing, controlling EVs, making it more realistic with mundane realism, train your observers, make sure the researchers are behaving the same way every time. And then the next bit is basically paper two stuff. So these are just some tips about the descriptive stats section. So always read the question. What are they actually asking for? Are they asking you to tell them a measure of central tendency? Are they asking you to say how it would be actually conducted? So usually put how on, they need an actual explanation of how you would do something. So really, really read that question. Always show your workings out on any mathsy questions because you get marks for the working out. Even if you've done it in your head, still just write how you would do it as a working out so that they can give you those marks. For ratios, usually the first thing they ask for is on the left of the colon, and the second thing they ask for is on the right. So that helps you understand how you do your ratio. Always simplify it. Same with fractions, always simplify them. And if you're stuck, try and half it. That usually helps. If you can't half it, divide it by 5 or 3 or something like that, something easy. So, for example, we've got he counted 60 pro-social acts and 15 anti-social acts. So it's 60 to 15, which is quite easy, isn't it? So we've got, that's the first one, that's the second one, first one, second one. Try and half it. Well, we can't half it because we get 30 and 7.5. So then maybe try putting it into fives. So we've got 12 and 3. And then again, will 5 go in? No. Will 3 go in? Yeah. So you can go 4 to 1. So you want to kind of make sure you're simplifying it in that way to the smallest form because that's what you get your marks for. For fractions, again, the total is always on the bottom and that what they're asking you for is always on the top. And if you put it in your calculator, the top one divided by the bottom, it'll turn it into a decimal for you. So you don't have to use the fraction button, you can just put it into your calculator in that way. So for example, we've got a study of 23 5-year-olds showed that 17 showed signs of egocentrism. Calculate the number of 23 children. Well, the total is on the bottom, that's 23, and what they're asking for is 17 of them. So it's 17 divided by 23. When you put it in as a decimal, you get 0.7. And then obviously if you get asked to round it to two decimal places, 0.74, they might also ask for significant figures though. So again, you've got to read what they're actually asking for. Notice you've got to make sure that we're rounding properly. So whatever the number is, so we've got two decimal places, so we got this one. If this number here is 5 or above, we've got to round up. If it's below 5, then we can keep it as 7.3. So this trips a lot of people up. So you've got to make sure you're doing that on your answers. It might say one decimal place, so I'll make sure you read it. For percentages, it's easier to do percentages if you write them as a fraction and then put them into your calculator and divide by 100. Again, same thing, total's always on the bottom. What they're asking for is on the top. So for example, in this one, we've got 198 males, 175 females. Calculate the percentage that were female. So you add these two together to get the total, put that on the bottom. And then you want the female, so it's 175 on the top. So we've got that, times it by 100, and then you get your percentage, nice and easy. Again, it might ask you to do it to decimal place. This one says 1 decimal place, so we've got it to 0.9. So the ones after that have obviously been rounded to the appropriate one. So it's nice and easy once you remember how to do it. Standard form, they like to ask about standard form. This is an example question here. So if it's a really, really big number, then the little number is going to be a positive. If it's a really, really small number, like 0 point blah, 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 the number will be negative. So that'll help you remember which way around that is. It's always whatever the number is, times 10, and then how many it is. So say, for example, with this one, you want 3.2, so you always kind of do it like the first number, point, whatever. If there was a number there, it'd be 3.2, whatever that one was, times by 10. And then the way that I do it is imagine the decimal places here, counts. We've got 1, 2, 3, 4, 5, 6. And I'm assuming you can see my mouse actually, maybe you can't see that. So we've got times 10 to the power of 6, because each of these columns here is a times 10. That's why I put the times 10 on. And then it's 6 times. Again, they like to ask this one, but they usually ask the standard form questions in the development topic, so they might come up in another area rather than on the research methods bit. Significant figures, this one, so we've got an example here. If So I've just put like an example here of a fraction that's then turned to a decimal into a percentage. Say you've got this as a percentage and it wanted it to two significant figures. A significant figure is like a number that's not a zero, basically, that it starts with. So for example, here we've got two significance of 69, and then afterwards the number after it is a zero, so there's no rounding required, so it's just 69. If this one was like a 9, then this would round it up to a 70, and then your two significant figures would be 70. It might be that it starts with a zero. So say this, for example, we were putting this to two significant figures, that it would still be 0.69, because a leading zero is not a significant figure. And then a normal distribution is one that looks like this. So this is a bell curve. This means that the mean is in the middle. 50% of the scores on this side, 50% are on this side. And it's sometimes called a bell curve. So the mean, the median, mode are all in the middle of that one. They sometimes ask you like to either draw a distribution graph or identify it. So you need to know the difference between these. Whereas these ones here are skewed. So this means that and the way that I remember this is, for this one, if you are a positive person, if you imagine this is one person, this is another person, you want to get close to others and you want to give them a hug. Whereas if you don't like people, you're quite a negative person, you might want to keep them as far away from you as possible. So this is the person, they're keeping them away from them as far as possible. I'm assuming you can see my cursor, otherwise it's going to be really complicated for you to. I'm looking at the diagram at the top if you can't see my mouse. So as you can see, the one that's kind of away from the axis is a negative skew. The way that's close to it is a positive skew. I've never forgotten it since I remembered it that way. And what this means as well is if you've got a positively skewed distribution, it means that your test was too difficult because you've got people scoring lower. Whereas a negative skew means that your test that you did was too easy because loads of them are scoring really high. Obviously, it might not be that they're doing a test, but that's generally the context of what they might ask you about it. Also, you have to be able to make estimates. So they might ask you to estimate something. This is where you've got to round the numbers to the nearest 10 or 100 or 1,000. You should be able to do it in your head. So if you're having to use a calculator, you're not doing it properly. So for example, this here, if I was to round this, I'd do 600 times by 30. And then that is 6 times 3, which is 18, and add the 3 noughts on to get 18,000. So nice, easy. You should be able to do it really, really quick in your head for an estimate. They don't ask many questions on estimates, but they have asked them in the past. It is on the specs. You need to know how to do those. And then you might be asked to do a table or a graph. Sometimes they've asked you to do like a tally chart, like this one here, like an empty one. So like how would you do it as like a tally chart? So sometimes you might be asked to do that. You might be, so this one is called a frequency table if it's a tally. So you could be asked to draw an empty tally chart. You are usually asked to read tables as well. So imagine that these digit spans are not here, you would be putting like that as a telly. So you've got to put the titles, you've got to put the different categories, the different levels of the IV, for example, in there. You might be asked to do a bar chart. Key things to remember at a bar chart, your bars do not touch each other. They also don't touch the axis. They've got the same gap in between them. They all should be that same width. And they look for differences. So very good if you've got an experiment. If it says to suggest an appropriate graph, then a bar chart would be good. If it's a correlation, you want a scatter graph, as we've mentioned before. Make sure there's a line of best fit on there. So you could be asked to draw these or say which one's appropriate and why. They do like to ask about pie charts. They often put the circle on for you. So you might want to have a protractor, but you can just do a sketch. So if it's an easier one to kind of know, you can sketch it, but you might just want a protractor just to make yourself feel more confident about what they are. So this is the way that you would calculate it. So you've got the percentage divided by 100, which is what we've done before when we were doing it with the fractions and percentages. But this time you're going to just times it by 360, and this will give you the degree of each segment. So you could like times it, like, so once you get your degree of segment, then you've got to times it by how much it was to get the kind of degree of that segment. So this is what this is saying. So we've got the number divided by the total times by that, gets you the degree of segment. It's not the same thing, actually. I think it's just a different way. Oh, the reason why I put that is because sometimes you pie charts, the results are in percentages, sometimes they're in numbers. So this will tell you kind of like how to do each one. And sometimes they've asked about what's the modal class. The modal class is just the biggest one, it's the biggest pie segment. They might ask for line graphs and histograms. Rare, they don't often ask these. A line graph usually shows you change over time. So that has been on before for when people get older, for example. That one needs a line to connect them. It's a bit like a scatter graph, but you connect it to the axis and kind of do a line over time. Whereas for a histogram, this one, the bars do touch, they do touch the axis, and you would need to calculate the frequency divided by the class width to be able to put those on. So that one might be one to practice if you have a look on past paper questions that I added on Teams, because they don't ask it very often. It's a bit more complicated. This is an example here of how you would do it. So if you've got unequal class widths, so we've got these here, you'd have to calculate frequency density. If you've got equal class widths, you can just plot it against the frequency. So it does depend on, usually the class widths are equal, so it's not as complicated because this is more of like a mathsy question. But yeah, you might want to practice that one. You might be asked to write a conclusion, although these are generally for A level, but you might have to, which is basically what's been found. So you don't put a finding in it, you kind of just put like generally what was the outcome. So lyrics are more likely to affect concentration than non-lyrics, for example. And this might be because it's confusing because the lyrics are in there. So you need like a little bit of an explanation. But I don't think that you would need this one, to be honest. It's not really come up very often. And then finally, measure the central tendency means mean, median, and mode. A lot of people got confused on the paper last year because they were like, what's a measure of central tendency? And it's like, well, it's a mean, median, or a mode. And you need to be able to suggest one of these and say how you would calculate it. And I don't think you need a strength or weakness of these actually, but you would if it was like an A-level paper. So I don't think you do need those, but you need to know what they are. So for example, a mean, you add all the scores together, divide by how many there are. You need to put your answers in context. You need to say what are you adding up, what you're dividing by, because some people get that wrong. Median is you put them all in order from smallest to largest, or largest to smallest, doesn't matter which order, and then you kind of go into the middle to find the middle value. If you've got two in the middle, you add them up divided by two. Then mode is the most frequently occurring, the most common, or the biggest slice of pie if it's a pie chart. And then the range is a measure of dispersion. So they might use this terminology. So you want to say the biggest number minus the smallest, or the smallest taken away from the biggest. Some people say smallest take away biggest, so they miss out the from bit, which doesn't make any sense because you can't take a big number away from a small number. So you've got to be really careful that you get that the right way around and obviously put that into context. So I made a booklet for you so you can play that to test yourself on all of this. And obviously I'll do another video on section D. So hopefully that was helpful. Any questions, just let me know.